Okay, so now let's have a look at question 7. So the continuous random variable x has a distribution with a probability density function given by f of x, such that ax outside of 5 minus x if x is between 0 and 5, and f of x equals 0 if x is outside of 0 to 5. So a is a positive constant, and we've been asked to find the value of a. So the important thing here is that whenever we're asked to find a in a question like this, is that we know that the area under the PDF is always equal to 1. So that means that the integral of f of x dx equals 1, which is the same as saying a outside the integral of 5x minus x squared dx equals 1. Alright, so a is a positive constant, so I can take it outside of our integration. And sorry, I should have said that this is only equal to 1 between our terminals, between 0 and 5. So now we know that this integral can be expressed using the fundamental theorem of calculus as 5x squared on 2 minus x cubed on 3 between 0 and 5 equals 1. And again, we just leave our a out the front as a constant term. So this implies that a outside of, f of 5, take f of 0, so f of 5 is 5 outside of 5 squared on 2 minus 5 cubed on 3. Take f of 0, which is just 0, equals 1. Therefore, a outside of, so 5 times 5 squared is 5 times 25 is 125 on 2. Take 125 on 3 equals 1. This inside here, 125 on 2 minus 125 on 3, works out to be 125 on 6 equals 1. So now all we do is we multiply by 6 and divide by 125, and we isolate a is equal to 6 divided by 125. And that's the answer for part A of this question. So next it says that we want to find the probability that x, our continuous random variable, is less than 3 as a definite integral, but we don't have to evaluate it. Okay, so it's just 1 mark. We've just got to express it as our definite integral. So we know that the probability that x is less than 3 is equal to the integral of a, so now we have 6 divided by 125 times x of 5 minus x dx, where our terminals are between 0, our lower bound, and 3, our upper bound. So that's the answer for our definite integral, and we don't need to solve this for the question. Alright, so that's the answer to part B.